I will be doing video number 6B. A 60-kilogram woman is in an elevator accelerating upward at 0.8 meters per second squared. Draw a free body diagram for the woman and calculate all forces on her. Then draw a free body diagram of the elevator, which has a mass of 200 kilograms, and calculate all forces on it, ultimately determining the tension in the rope. Okay, so pretty much what this question or the prompt is that we get this diagram of a woman, it looks like a man or a stick figure, in an elevator that is going upward at 0.8 meters per second. So this whole system is accelerating upward at 0.8 meters per second squared. And the woman or the person inside of the elevator has a mass of 60 kilograms, and the elevator itself is 200 kilograms. And it's asking us to draw a free body diagram of the person and the elevator, and to calculate all the forces in those free body diagrams. Okay, so for the person, the free body diagram is just the force of gravity downward and the force normal upward. The force normal is the normal force from the bottom of the elevator going up, and the force of gravity is because of the weight of the person pushing onto the floor of the elevator. So those are the two forces for the person. And so let's calculate the forces on the person before we go on to the free body diagram of the elevator. So we know it's force normal and force of gravity. And the formula is F equals ma, or all the net forces is equivalent to ma. So you do force normal minus force of gravity equals ma. So the reason why we do force normal minus force of gravity instead of force of gravity minus force normal is because the elevator is accelerating upward in the positive direction, as you can see by this arrow, at 0.8 meters per second squared. So it's going up. Therefore, force normal is positive and force of gravity is negative. So it would be force normal minus force of gravity equals ma. Then we know that force of gravity is mg, mass times gravity. Then you solve it for force normal is equivalent to mass times gravity plus acceleration after you factor m out. And you can plug in everything else after that. So you get force normal is equivalent to the mass, which is 60, mass of the person, since this is the free body diagram of the person, times g, which is 9.81 meters per second squared, plus the acceleration of the person, which is the person is accelerating with the elevator upward at 0.8 meters per second squared. So you would add those two accelerations together, and you get force normal is equivalent to 636.6 newtons. And we already solved for the force of gravity before we even did the force normal, but I'll put it here. Force of gravity is equivalent to mg, as we stated before, which is just the mass of the person times the gravitational acceleration, which is 9.81 meters per second squared, and that's the force of gravity. So the force normal is bigger than the force of gravity since the person's going upward in the elevator and it's pushing down harder. So that's the force normal and the force of gravity of the person. Now let's look at the free body diagram of the elevator. For the elevator, the only two forces are the force of gravity downward and force of tension upward, because there's a rope right here that's holding up the elevator. And so the same formula, F now equals ma. Again, we would do force tension is positive and force of gravity is negative, because the elevator itself is moving up in the positive direction, so force of gravity will be negative. So you would do the same thing with force of tension minus force of gravity. You factor out m and you get force of tension is equivalent to mass times gravity plus acceleration. But in this situation, since we're doing the free body diagram of the elevator, we have to include the person inside for the mass. The whole elevator includes the person. So for that mass, it'd be the mass of the person plus the mass of the elevator, which would be 60 kilograms plus 200 kilograms. So 60 being the person, 200 being the elevator, and then you get a total mass of 260 kilograms. So the force of tension would be mass, which is total mass, 260 kilograms, times gravitational acceleration, 9.81 meters per second squared, plus the acceleration of the elevator moving upward in the positive direction, which is 0.8 meters per second squared. And you multiply that out, you get force of tension equivalent to 2,758.6 newtons. Then we've already solved for the force of gravity before we even solved for force of tension. But to do it again, we would do force of gravity is equal to mass of the person plus mass of the elevator, as we stated before, times the gravitational acceleration. So that would be 260 times 9.81 meters per second squared to give us 2,550.6 newtons. So that's the force of gravity and the force of tension of the elevator in free body diagram. And this relates to what we've been recently learning in class, because we've been learning about Newton's second law, which is F equals ma, and we applied Newton's second law in the situation. Thank you.